Hey guys, I'm going to first take you through my activity because I've recorded this a couple of times and I can't seem to get it under 5 minutes. So I'm Jamie Smith, high school science instructional coach, and here's my SNAP activity, and then I'll talk about product and the lesson plan afterwards. This is a review activity for cellular differentiation, showing kids how DNA codes for proteins, which will influence stem cell production and differentiation in fetal development, which is a need for us to have some activities and to improve in terms of test scores. So here's my activity. Hi, what's your name? It's going to be Jay. Well, it's going to be Jay when it recognizes that I'm typing. Here we go. Okay, you can call me Miss Smith. The timing on these are a little off. Today we're going to explore DNA proteins and how they differentiate during development. I keep trying to fix the timing, but it does not listen to me. Press the space bar when two gametes come together to form a zygote, and basically it says stem cells. These cells are blank cells with no function. How do they develop into different kinds of cells or differentiate? We will explore this question today. And press the letter Z to continue. All right, now she's pregnant. Signals from the pregnant mother's body turns certain segments of DNA in the stem cells on for developing zygote, basically. This DNA that is turned on is called express DNA. Now the cell can use express DNA to code for proteins. Once the right proteins are made, the blank stem cell becomes specialized cells such as skin cell or red blood cell, and let's practice this process. All right. Recall the DNA first codes for mRNA and mRNA codes for proteins. I have a question for you. All right, what part of this cell is DNA found in? If you put in the wrong answer, she says, oops, try again, and then repeats the question. So the correct answer is A, the nucleus. So we're going to begin in the nucleus. Press the letter X. Now we're in the nucleus. We're going to basically code the DNA into RNA. Okay, so if I put in a wrong answer here, coding the DNA into RNA, she'll say, oops, and give me a reminder that there's no T in RNA. Let me code it correctly, GUC, and GUC is correct. And so we go through, trying another one, and I'll just put the correct one in here for CUA. CUA is correct, woohoo! And the codes will code for different amino acids and the proteins to help create different cells in the zygote, which is what we're doing. You need a codon chart for this next activity, and also one will appear. Let's code for some amino acids. And so we're going to press W. Here's our codon chart. So there's an incorrect answer option on this one too, but I'm going to go through it quickly. So this is Val. Valine is correct. Yay. The true name for this is Valine. Let's try another one. This is leucine. Just kidding. LEU. Yay. Leu is correct. The true name for this is leucine. And great job. Press V. My DNA has coded for proteins valine and leucine. So what she said there. And see, there's this blank time. Muscle cells are primarily made of valine and leucine. So yay, we made some muscle cells. My stem cell in my zygote has become a muscle cell. Need to fix the spelling there. You are on your way to creating an entire differentiated organism. Press U to continue. And I added some sound with my voice. My goal is that teachers will want to make these for their students, and saw how easy mine was. Here's my lesson plan real quick because I know I don't have a whole lot of time. This is not the first time students will see this activity or this kind of information. So I've got like codon bingo and bingo boards in there. I've got some notes and a concept map and guided notes for students. And I'm working on finishing my lesson plan, but I want to get this video uploaded. So I'm going to go ahead and stop. Basically for the product elements, obviously there's a lot of patterns with coding proteins. There's a bit of abstraction because I've got some things running in the background. There's lots of, let's see if I can get back to the lesson plan before my time runs out. Here's where I have my product elements, decompositions, breaking down the process, and algorithms. Protein synthesis is an algorithm in itself because it's lots of steps. All right, that's it. I made it in 5 minutes. Thanks, guys.